Hey Cougars, I'm Mr. Franklin, and in this video we're going to look at two separate issues. The first thing we're going to look at is what's called a gradient sort. It's a tool that we're going to use to sort different ideas to help us figure out which ideas, evidence, um, arguments fit better for different things. So it's going to help us sort our thinking. Then we're going to talk about, and we're going to practice this tool or use this tool to talk about fact, theory, and law and distinguish between those three ideas. So first off, a gradient sort or a gradient, the word gradient literally means change. So in more advanced math classes, you'll actually use the word gradient for the same thing as slope because slope means rate of change. Well, a gradient in upper level math actually means the same thing. You might also see it in color. So when we do a gradient in terms of color, you might see one color change from to another color. So in this case, what we've got is we've got black, gray, and then white. So we're going to have this color change. So we're going to use this gradient pattern to help us sort many ideas throughout this course and build our argument skills in science. So black or solid, we're going to place things that fit our category, the things that fit the best, we're going to place them in the black box up here, okay? If it's gray or fuzzy, we're going to place things that kind of fit, they might fit, or part of them is true for the category, part of it's not, maybe we're not quite sure, but it might fit. And then the white or nothing space, it does not fit. So we're going to drag the images or objects to the box that matches kind of where it fits the overall topic. And then later we're going to be able to explain why did we place it in the correct place. So here's an example that you're going to see when you get this homework, but you're going to get a topic. So in this case, a fact, and there may be an image or a short video clip of a situation that I want you to think about when you're sorting this information. Okay, so this one is a fact, and we've got the car's mass has a mass of 6,000 kilograms. So we drag that up to the black box because it fits the most. The car is white. Maybe it does fit. It is a fact, but maybe there's some confusion as to what color the car really is. Maybe it's not completely white. We could make an argument, so maybe I put it in the middle. And while the force of gravity in this equation is true, it's actually a law. So it really doesn't fit the category of a fact. It's going to fit a different category. So I put it down here. Okay. We could also put like the car is blue. We could put it down here. So that's kind of how it's going to work. But let's do a couple of examples and try it out. So in order to do that, let's review what our terms mean. So first, a fact is a piece of information that has an objective reality. So it's true no matter who the observer is. So for example, if I measure a piece of paper that's 8.5 inches by 11 inches, somebody else could pick up the same piece of paper and get the same measurement. That would be a fact about that piece of paper. So a scientific fact specifically is a measurement that is qualitative or quantitative. So make sure you know those words from your vocab, and it can be verified or measured by someone else. So for example, the example from our video that we watched last week, if it's bright outside, that's a statement of fact. We could say it's bright outside. And if you had a light meter, you could actually give a number to that with a unit of measurement. A hypothesis. A hypothesis is a proposed explanation of an observed phenomenon. It must be tested, and it's the starting point for developing a test. So we observe that it's bright outside, and our hypothesis is it's bright because the sun is out. So it kind of answers the question of why is it bright? Okay, so the sun is out. That would be a hypothesis. Then a theory would be a well-substantiated explanation tested through the scientific method, repeatedly tested and confirmed by observation and experimentation, and can be used to make predictions. So we see that it's bright outside. We go outside and look. Wow, the sun is out. It's bright outside. We go outside and look. Wow, the sun is out. So now we have a theory that every time we see that it's bright outside, the sun must be out. Okay, so that's a theory. Now we could actually shine a really bright light outside, and then now we would have to adjust our theory. A law is a detailed description based on repeated observations, and it is mathematical in nature. And it usually doesn't describe the why. So a theory generally describes the why or how something is working. The law just explains what's happening in a mathematical sense. So for example, the inverse square law for the brightness of a light source, there is a mathematical equation that tells us how bright light is based on its distance from the object, based on the area that it illuminates, all those kinds of things, and we can actually calculate brightness. We change the distance, the brightness is going to drop by a square of the distance. Okay, so that's a law. So we're going to use those definitions, and now we're going to do a couple of sorts. So I'm going to do this one first. I'm just going to work through it. Follow along with your example and see why I picked the choices that I make. And you may disagree, and that's okay. There's a place that we're going to see in a second where we're going to explain that. So here's how this assignment's going to be set up for you. You're going to have a key term, and you're going to try to find facts that explain what you see and observe in this picture. So it looks like we have a truck pulling away. We have a car falling. So now let's go look for some facts. So facts are observed. They can be measured. They're usually quantitative or qualitative. So to me, that's what I'm looking for is qualitative, which is like a description or a comparison, or quantitative, which is a number that deals with the object. So first one, the truck moves forward at 10 meters per second. That has 10 meters per second. That has a number. That sounds like a fact to me. Newton's first law is acting on the car. So that may be true, but that sounds like an explanation of what is happening and not an observation of what is happening. So honestly, I'm kind of not sure at the moment, so I'm going to put that right here for now, and I might move it down here in a minute as we go through this. Force of gravity, I've already said it was a law, so it is a law. It is not a fact in the pure sense of the definition, so I'm going to put it down here. The mass of the car is 6,000 kilograms. So that, I could measure that. Somebody else could measure that and see if that's true. That sounds like a fact. So I'm going to put that up there. I don't like the way the car looks. That sounds like an opinion. So that is definitely not a fact. The car is blue. The car is not blue. Or at least I don't think it's blue. So I'm going to put it down there. The car is white. So that's an observation. Can someone else see it as white? Possibly. There's no number with it, but it is qualitative. Okay, it describes the object. We could say it is white compared to the truck around it. If we had a different color of white, we might argue what kind of white it is. Okay, so that's a qualitative measurement. The next one, the car falls because gravity pulls the car to the ground. So that sounds like an explanation. So yeah, gravity is acting. I know that, but that's not a fact so much as it's kind of a fact. So you see how we might be able to argue this where this falls, but is it a measured reality? Is it a measurement that we actually can observe or make from this image? No, so it does not fit up here. So let's go back. I said I was thinking about this one. Newton's first law is acting on the car. My physics brain says, yes, I know that's true, but that's still an explanation. So we could actually probably argue for both of these to go down here. We could also make an argument that they go up here because they are true, but they are not measured realities that have to do with this, which means this might actually go up here as well. So the gradient sort, the most important thing about this is being able to explain why you put your answers where they are, and also be willing to change your answer if you realize that you made a mistake or someone else gives you some input that makes it clearer. Okay, so that's all well and good. I've done the sort, but now for your assignment, you actually are going to need to tell me why you put certain things in the category. So explain what rules or thinking you use to put the items in the solid category. So it says put your answer here. So I picked observations or measurements that were quantitative and qualitative. Notice what I'm doing here when I write this. Oh, I gotta spell that correctly. When I write this is I'm actually using the definition of my fact to help me explain why I picked it. So it's a measurement that is qualitative or quantitative. So it has a number, or it's a comparison, or has some kind of value or description to it. Okay, can be verified or measured by someone else. So I picked observations or measurements that were quantitative and qualitative. They could be measured by someone else who should be able to get the same answer. Okay. So notice I'm only going to explain what I put in the solid because that's what the question asks for. This becomes a little trickier if I ask you, why did you put things in the gray category? Okay, so now you have to kind of think about what definition those fit. So if I'm answering the gray category, then I may have to do some more thinking. But overall, that's actually not too difficult. So I sorted what I observed, and now I'm explaining why those went there based on the definition of what a fact is. Okay, so now let's go and let's try one.